I'm going to present a video on limit state method examples of singly reinforced beam. So please kindly subscribe to Civil E-Learn for more videos. Here we are having two types of problems, that is analysis of the section and design of the section. This is the analysis example. In this case, the cross-sectional dimensions of the section is given and the area of the tensile steel is also given. So finally we have to calculate the flexural strength of the beam section by using the details. The width of the section is 250 mm and the total depth, that is 450 mm. In this case, the effective cover is given, that is 50 mm is the effective cover. So effective depth is equal to 450 minus 50. So finally it is 400 mm and AST is equal to 3600 mm square, which is already given in the problem. So we will see how to calculate the flexural strength of the beam section. So first of all, we have to calculate the actual depth of neutral axis. The formula is x nu by d is equal to 0.87 Fy AST by 0.36 FCK PT. By substituting the Fy, AST, FCK, B and effective depth values, we will get x nu by d is equal to 1.805. So after calculating the x nu by d value, for Fe415 steel, the xu max by d value is 0.48, which is already given in the IS 456 code. Then compare the x nu by d value and xu max by d value. Xu by d is greater than xu max by d, so the section is over reinforced. So the moment of resistance formula with respect to concrete is equal to 0.36 FCKB x nu into z, that equal to 0.36 FCKB xu max into d minus 0.42 xu max. As the section is over reinforced, the concrete will fail early, so we have to take the mu limiting value with respect to the concrete. So finally mu limiting is equal to 0.138 FCK BD square by substituting the xu max value of 0.48 in the mu limiting equation. So finally substitute all the values, that is FCK is equal to 20, B is equal to 250 and D is equal to 400. Finally we will get 110.4 into 10 power 6 Newton mm. So finally it is 110.4 kilonewton meter. So this is the flexural strength of that particular beam. Next problem, limit state method. Calculate the flexural strength of the beam section. The beam width is 350 mm and total depth is 750 mm and the effective cover is 50 mm. So here we are given two numbers of 25 dia and two numbers of 28 dia, area of steel in tension zone. So calculate the AST value by using these diameters and calculate the flexural strength of the beam section. So first of all, calculate the depth of neutral axis. Actual depth of neutral axis formula is x nu by d is equal to 0.87 Fy AST by 0.36 FCK BD. So substituting the Fy value, AST value, FCK value and PD values, we will get x nu by d is equal to 0.453 and the xu max by d value is 0.48 for Fe415 grade steel. Compare the values and in this case x nu by d is less than xu max by d, so the section is under reinforced section. So for under reinforced section, mu is equal to 0.87 Fy AST into d into 1 minus Fy AST by FCK BD. This is the formula which is already given in the IS 456. So substituting the all values, we can find out the moment of resistance. After substituting all values, mu is equal to 454.513 to 10 power 6 Newton mm So that is mu is equal to 454.513 kilonewton meter. That particular beam section can resist up to a moment of 454.513 kilonewton meter. Next, this is the design of a singly reinforced beam section. In this case, the width is given, small d is given, and capital D is given. Factored moment is given. So we have to calculate the area of tensile steel by using the grade of concrete of M20 and Fe4 and 5 materials. First of all, we have to calculate the limiting moment of resistance. So that is mu limiting is equal to 0.138 FCKBD square for Fe4 and 5 grade steel. Substituting all the values, we will get mu limiting, that is 377 into 10 power 6 Newton mm. So that is 377 kilonewton meter. Mu value is already given in the problem, that is 185. So 185 is less than 377. So the section is under reinforced. So for under reinforced section, mu is equal to 0.87 FYAST into D into 1 minus FYAST by FCKBD. In this case, we know all the values except AST value. Substituting all the values, we will get the area of steel in the tension zone, that is equal to 830 mm square. In this case, we have to use mu is equal to 185 kilonewton meter. So by using the 20 mm diameter bars, we have to find out the number of bars. So first of all, how to calculate the number of bars means AST, that is total AST divided by pi by 4 into 20 square. We will get n is equal to 2.64. So 2.64 provide three numbers of 20 mm diameter as tension reinforcement. So after calculating this reinforcement, we have to draw the section. So like this. In this case, the width of the section is 300 and total depth is 725. In this case, three numbers of 20 mm diameter we designed, and these are the anchor bars, and this is the stirrups. In the future videos, we will design the stirrups diameter and the spacing of the stirrups. This is another example of singly reinforced beam design. A simply supported rectangular beam of effective span is 6.5 meters subjected to a uniformly distributed load of 15 kilonewton per meter inclusive of its self-weight throughout its length. Determine the depth of the beam area of the steel by using limit state of collapse of flexure, by using M15 grade of concrete and Fe4 and 5 steel, and the width of the beam is restricted to 300 mm. First of all, in this case, the total uniformly distributed load inclusive of self-weight is given as 15 kilonewton per meter. This is the service load. We have to convert this service load into factored load by multiplying with the partial safety factor, that is 1.5 for loads. So 1.5 into 15, that is 22.5 kilonewton per meter. Then calculate the ultimate moment. Mu is equal to WL square by 8, as this is the simply supported beam subjected to a uniformly distributed load throughout its length. So the formula is WL square by 8. So W is equal to 22.5 into L is 6.5 square divided by 8. We will get 118.828 kilonewton meter. So calculate the mu limiting value, that is mu limiting is equal to 0.148 FCKBD square. Substituting mu limiting and all the values except D value, we will get D is equal to 437.5 mm. So finally provide an effective depth of 440 mm and overall depth of 480 mm by assuming the effective cover as 40 mm. Then equating the total compression and total tension, that is 0.87 Fy AST is equal to 0.36 FCKB XU max. We will get AST is equal to 947.6 mm square. So finally, using 20 mm diameter, calculate the number of bars. Finally, provide 4 numbers of 20 mm diameter of steel reinforcement in tension zone. So this is the final diagram. In this case, the width of the beam is 300, total depth is 480, and effective depth is 440 mm. And we got total 4 numbers of 20 dia. And here we are providing anchor bars of 2 numbers of 10 mm diameter. Here the purpose of anchor bars is to support the stirrups. We should require the compression steel. Here we are using the minimum diameter of the bars for beams, that is 10 mm of 2 numbers. Thank you for watching. Please subscribe to Civil E-Learn for more videos.